All right, so the last thing we're going to talk about is the growth and decay rate. So last time when we talked about our word problems, we would set up our word problems and you would end up with these values inside your parentheses right here, which if you remember we referred to those as our B value. So if we had a times b to the x, it was our b value because it's what has the exponent on it. So that value is what we refer to as the growth factor or the decay factor, depending on if it was increasing or decreasing. So what they want to know sometimes is what is the actual growth rate. So we know what the growth factor is. They want to know the actual percent that it's increasing by or the percent that it's decreasing by. So if the number is greater than 1, like for example this first one here, 1.04, that's greater than 1. So the way that we would get that value is that it was 1 plus the rate. So I'm going to say 1 plus the rate has to equal my b value of 1.04. So then to solve for my rate, which is what I want, I would subtract my 1, and I'd get that my rate is 0.04. And that's the decimal form of it. What would my percentage be? Move that decimal over 2 places. This would be 4%. So this is 4% growth. Now some people don't need to go through all of that. They can look at it and just know because of the 0.04 it was 4% growth. And that's fine. If you can, go for it. But if not, that's how we got it. It was 1 plus the rate, so you got to subtract the 1, and then that gives you your growth rate. So now for 2, my b value here is less than 1. So that means it was a decay problem. To get the value, I had to do 1 minus my rate. Because it was decay, we had to subtract it out of there. So 1 minus the rate gave me my 0.80. So then like that last one, I'll subtract my 1 to try to solve for r, just like any normal equation that we would have there. So 0.80 minus 1 would give us negative 0.20. Then we would just have to divide by negative 1 here. And we would get that our rate is 0.20. So as a percent, though, what would that be? 20%. And again, this one was decay, because the value was less than 1 to start with. So 20% decay. Some people can, and some people can't. So I'm teaching a strategy for the people who can. So for the third one, would this one be growth or decay? Good, decay, because it's less than 1. So that means it was 1 minus the rate is how we got 0.95. And again, some people can do it in their heads. So if we subtract the 1, we get negative 0.05. Divide by negative 1, and what's our rate? Yeah, 5% decay. So 5% decay on that one. Now those ones are nice and easy because our exponents were all x's. So you just take your b value and you figure out growth, decay, and then by how much. So for number 4, 5, and 6, though, it's not as easy because if you look at your exponents, they're not just x's anymore. There's something along with it. So you can't just look at your b value like we did for the other ones because that exponent needs to be simply an x. So what we have to do for these ones is, yes, you take that stuff inside of the parentheses. And for this one, because there's a 2 with the x, we have to square it first. we have to take care of whatever that other number is that's with the x. So in our calculators, we're going to type in 1.04 squared. 1.04 squared. And we get 1.0816. And now we do like what we were doing on the top. It's greater than 1, so that means it was a growth, so it would be plus. So subtracting our 1 to figure out what our rate is, we get 0.0816. So I move my decimal twice, and we get 8.16% growth. So it's going up by 8.16%. So again, that was only because our exponent wasn't just an x, it was 2x. So number 5, our exponent isn't x, our exponent is negative x. But really, what's our number here in front of x? We don't write it, but it's there. 1, that's really negative 1x. Negative x is the same as negative 1x. So again, I have to take whatever's in the parentheses, so my 0.80, and I got to raise it to the negative 1 power first. Because I don't want negative x, I want positive x, then I can figure out my growth or my decay rate. 0.80 to the negative 1. 0.80 to the negative 1 gives us 1.25. So that negative exponent actually took what we thought may have been a decay initially, and it's actually going to be a growth problem because it's 1.25. It's greater than 1. So remember, growth is 1 plus the rate. So our rate is 0.25. So that's 25% growth. So those negatives, they're always going to switch it to be the opposite. If it looked like a growth before, but it's a negative exponent, that means it's going to become a decay. If it was a decay to a negative exponent, as we saw, it turns it into a growth. So those negative exponents are tricky. So for number 6 there, we have x over 4. So what we need to do for that one is it's really 1x over 4, which would be 1/4 x. So we got to do the 0.95 to the 1/4 power. So again, I took everything away from the x. I took the 1 and the 4 away from the x. So my exponent would just be x. 0.95 to the 1/4 power. Gives us 0.98725. So that's our new exponent. So this one is what? Growth or decay? Decay, because it's less than 1. So it was 1 minus my rate is how I got there. Now that's a lot of decimals, so I'm going to round it. Actually, we'll go with this one. So really this 2 should end up being a 3. I'm going to do a little rounding because the decimal is a little long. So subtract my 1. 0.0987. Divide by negative 1. And we get 0.0127. It just turns them both positive. So then moving our decimal over, 1.27% decay. It's not decaying by much, but it's still decaying. So what you got to remember is if it's not just an x, you got to bring whatever's with the x into the parentheses and raise that number to that power. And then you can figure out the growth or decay.